In this video, I'll explain how to evaluate the limit of indeterminate forms using L'Hopital's rule. So the indeterminate forms are 0 by 0, infinity by infinity, infinity minus infinity, 1 to the power infinity, infinity power 0, 0 power 0, 0 into infinity. Now, L'Hopital's rule, which is also called as a Bernoulli's rule, is used when limit of f of x by g of x as extends to c is giving you an indeterminate form. So, in that case, you have to differentiate numerator and denominator separately. Then you have to apply the limit. That is, limit of f dash of x by g dash of x as extends to c. This gives you the same value as that of this limit. In case if this value is also indeterminate, then you have to go with the next derivative. This value is same as limit of f double dash of x by g double dash of x as extends to c. So this is the main concept behind L'Hopital's rule. I have not defined L'Hopital's rule formally here. I have just specified the concept of L'Hopital's rule. Let us solve problems. Now see here, before solving the problems, we will segregate them into these 5 types. The first type is 0 by 0 form, second type is infinity by infinity form, and in these remaining types, we can convert either to 0 by 0 form or infinity by infinity form. Then we can apply L'Hopital's rule, because L'Hopital's rule is specifically for indeterminate forms 0 by 0 and infinity by infinity. In the third type, 0 into infinity form, which can be converted either to 0 by 0 form or infinity by infinity form. Type 4 is infinity minus infinity form. Type 5 is 1 power infinity, 0 power 0 and infinity power 0 form. So let us see how to evaluate these kind of indeterminate forms using L'Hopital's rule. And one more thing to notice is that 0 by infinity, infinity by 0, infinity into infinity, infinity plus infinity, infinity power infinity, 0 power infinity. These are not indeterminate. Now see the first problem. Evaluate limit extends to 0, x minus sin x divided by x cube. The first type is here 0 by 0 form. Now when you apply the limit here, you can see 0 minus sine 0 is 0. So 0 by 0 form. This is in 0 by 0 form as per the L'Hopital's rule. Now you have to differentiate numerator and denominator separately. Then you have to apply the limit. Derivative of x is 1 minus derivative of sine x is cos x divided by x cube derivative is 3x square. Not applying the quotient rule, you have to differentiate numerator separately and denominator separately. Now apply the limit. Here 1 minus cos 0 is 1, 1 minus 1 0 divided by 0. Again it is 0 by 0 form. So this is equal to, hence once again you have to differentiate, limit extends to 0. Once again you have to differentiate this function now. Separate numerator and denominator separately. Derivative of 1 is 0 minus derivative of cos x is minus sin x. So minus of minus plus sin x divided by derivative of 3x square is 6x. So now here you can either directly go with the formula sin theta by theta, limit theta tends to 0 as of 1, that formula, or else you can apply the L'Hopital rule once again. So here I will just take 1 by 6 outside, then limit extends to 0, sin x divided by x. We know the formula, limit extends to theta tends to 0, sin theta by theta, this value is 1. So 1 by 6 into 1, the final answer is equal to 1 by 6. This is the value of the limit. See the type 2 infinity by infinity form. So evaluate this limit. So when you apply the limit here, 3 infinity square plus infinity plus 4, this value will be infinity divided by, when you apply the limit extends to infinity, this also gives you infinity. So this is infinity by infinity form. Hence you have to apply the L'Hopital's rule, that is differentiating numerator and denominator separately. So derivative of 3x square, derivative of x square is 2x, 3 2s 6x plus derivative of x is 1, derivative of 4 is 0 divided by 5x square, derivative is 10x plus 8. Now, when you apply the limit once again, you will get infinity plus 1, which is infinity by infinity form. Hence, once again, you have to differentiate this. numerator and denominator separately. Limit extends to infinity. Derivative of 6x is 6 divided by 10x is 10. So when you apply the limit, it is independent of x now. The answer is 6 by 10, which is equal to 3 by 5. So this is the value of the limit. See, type 3 problems are in the form 0 into infinity form. So usually L'Hopital's rule is applicable for 0 by 0 and infinity by infinity kind of indeterminate forms. Now if you have any indeterminate form as 0 into infinity, then you have to convert it into either 0 by 0 form or infinity by infinity form, so that you can go with the L'Hopital's rule. Now see here, this problem, evaluate limit extends to infinity x into e power minus x. So this gives you, when you apply the limit, infinity into e to the power minus infinity, which is nothing but infinity into 1 by e to the power infinity. E power infinity is infinity, 1 by infinity is 0. So it is 0 into infinity form. Hence, I have to convert it either to infinity by infinity form or 0 by 0 form. Let us see which conversion possible here. So just rewriting the terms. So x divided by e to the power x, so that when you apply the limit, you will get infinity by infinity form. So therefore, this is infinity by infinity form. Or else you can write it as e to the power minus x divided by 1 by x also. In that case, it becomes 0 by 0 form. Now apply the L'Hopital's rule here. X tends to infinity. Derivative of x is 1. Derivative of e power x is e power x. Now apply the limit. 1 by e to the power infinity. E power infinity is infinity. 1 by infinity equal to 0. Hence, the value of this limit equal to 0. Now, fourth type is infinity minus infinity form. So, in this case also, you have to convert it either to 0 by 0 form or infinity by infinity form, then apply L'Hopital's rule, because in some of the problems that conversion is possible. So see here, evaluate limit extends to pi by 2 tan x minus secant x. When you apply the limit, tan pi by 2 tan 90 degrees is infinity minus secant 90 degrees is also infinity. So it is infinity minus infinity form. Let us rewrite this to get it in either 0 by 0 form or infinity by infinity form. So limit extends to pi by 2. I'll write tan x as sin x divided by cos x minus secant as 1 by cos x. So denominator is same. So this can be written as limit extends to pi by 2. This is equal to sin x minus 1 by cos x. Now when you apply the limit, sin pi by 2, sin 90 degrees 1 minus 1 is 0 divided by cos 90 is 0. So it is now in 0 by 0 form. Therefore, you can apply L'Hopital's rule here. So I will write here limit extends to pi by 2. Differentiate numerator and denominator separately. Derivative of sin x is cos x minus derivative of 1 is 0 divided by derivative of cos x is minus sin x. So this is equal to, now when you apply the limit, cos pi by 2 is 0 divided by sin pi by 2 is 1. So minus 1, 0 by any value, it is equal to 0. Therefore, this is the value of the limit which is evaluated using the L'Hopital's rule by converting infinity minus infinity form to 0 by 0 form. Fifth type is when you have indeterminate forms 1 power infinity or infinity power 0 or 0 to the power 0. So in this case, you have to convert it into either 0 by 0 form or infinity by infinity form to apply the L'Hopital's rule. Let us see how to do that. Evaluate this limit extends to infinity x power 1 by x. So when you apply the limit, it gives you infinity power 1 by infinity, which is infinity power 0 form, which is an indeterminate form. So in this case, first you take this value as L, limit extends to infinity x to the power 1 by x. Take this value as L. Now apply log on both sides. This is the method. Log of L equal to log of limit extends to infinity x to the power 1 by x. Now there is a property of logarithm. that is limit log of limit is same as limit of log. So limit as extends to infinity, which is log of x to the power 1 by x. Now this can be written as limit extends to infinity log of x divided by x. That is because log of a power m is m into log a. So this gives you 1 by x into log of x. So that can be written as log x divided by x. Now when you apply the limit, it gives you infinity by infinity form. So apply L'Hospital's rule to get the value of the limit. So I will write here, we have log L equal to limit x tends to infinity log of x divided by x. Now differentiate numerator and denominator separately. Limit extends to infinity. Derivative of log x is 1 by x and derivative of x is 1. So this gives you, after applying the limit, extends to infinity, 1 by infinity is 0. But this is not the value of the limit. Log means it is natural logarithm here. We are taking the natural logarithm. You can write ln also. So here it gives you log L equal to 0. This implies L equal to e to the power 0. The inverse of log function is exponential e power 0. So that gives you the value 1. Therefore, the value of this limit equal to 1. Don't write it as 0. Don't stop here, because on the left hand side we have the expression log L. So log L equal to 0 implies L equal to e power 0, which is nothing but 1. So value of this limit equal to 1. Now see next problem, evaluate limit of tan x to the power x as x tends to 0. So when you apply the limit, tan of 0 equal to 0, 0 to the power 0, it is 0 power 0 form, which is an indeterminate form. Therefore you have to convert either to infinity by infinity form or 0 by 0 form. So any problems of type 5, you have to take log on both sides. That is, take L equal to this value, limiting value of this function, take it as a value L. Next, apply natural logarithm on both sides. Log L equal to, so log of limit is same as limit of log. So I'll write directly, limit extends to 0, log of tan x to the power x. Log of a power m is same as m into log a. So this is equal to limit extends to 0. So log of tan x into x, I will write it as 1 by x. So that is because, so when you apply the limit, this gives you log of tan of 0. Tan of 0 is 0. So log of 0 equal to minus infinity. Actually here it should tend to 0 from the right side. Here I should mention x tends to 0 from the positive side. So then it makes sense, log of 0 from the positive side, it gives you the value minus infinity. So this gives you minus infinity divided by 1 by 0 is also infinity. Minus infinity by infinity form. Therefore, now you have to apply L'Hospital's rule. So this gives you log L equal to derivative limit extends to 0. Derivative of log of tan x is 1 by tan x into derivative of tan x is secant square x divided by derivative of 1 by x is minus 1 by x square. Now I'll rewrite this as limit extends to 0. 1 by tan is cot x into secant square x divided by minus 1 by x square. Now cot is cos by sine and secant square is 1 by cos square. So 1 cos cancels. So you will get limit extends to 0. So I can take this to the numerator, so which is minus x square divided by, so what remains in the denominator here? 1 cos cancels, sin x and cos x remains. So cos x into sin x. Now when you apply the limit, it gives you 0 by 0 form. Here it is again 0 by 0 form. Just to avoid that infinity by infinity form again, I have made these simplifications. Now I got 0 by 0 form here. Apply the L'Hopital rule again. So this gives you limit extends to 0. So minus x square derivative is minus 2x divided by sin x into cos x derivative. This can be written as a sin 2x divided by 2. So derivative of sine 2x equal to cos 2x into 2. So here 2 cancels. So cos 2x you will get. Now apply the limit here. This is 0 divided by cos of 0 is 1. So 0 by any value equal to 0. Therefore, we got log L equal to 0. Hence, L equal to e to the power 0. The value equal to 1. Therefore, the limit of this expression equal to 1. Here, one more problem. Evaluate limit of sin x to the power tan x as extends to pi by 2. So, when you apply the limit, sin pi by 2 is 1, tan of pi by 2 is infinity. So, 1 to the power infinity form. For any of these forms, you have to consider this value as L, then apply natural logarithm on both sides. So, L equal to limit as extends to pi by 2 sin x to the power tan x. Now apply natural logarithm on both sides. Log L equal to, so limit extends to pi by 2 log of sin x to the power tan x. Now log of a power m is m into log a. So this gives you limit as extends to pi by 2 tan x into log of sin x. Now we have to write it in either 0 by 0 form or infinity by infinity form. So now when you apply the limit here, you will get 0 into infinity form. So I will write this as equal to limit extends to pi by 2 log of sin x divided by cot x, because 1 by cot x is tan x. So when you apply the limit now, sin pi by 2 is 1, log of 1 is 0 by cot of pi by 2 is 0, 0 by 0 form. Apply L'Hopital's rule. So you'll get limit extends to pi by 2 log of sin x is 1 by sin x into derivative of sin x is cos x divided by derivative of cot x is minus cosecant square x. So this is equal to, when you apply the limit, cos pi by 2 is 0, 0 by any value this 0 by cosecant square pi by 2 is 1. So 0 by minus 1, which is equal to 0. Therefore, log L equal to 0, which implies L equal to e power 0, which is equal to 1. The value of this limit equal to 1. Therefore, under type 5, we have 1 power infinity or infinity power 0 or 0 power 0, which have to be converted into either 0 by 0 form or infinity by infinity form by taking this particular value as L and applying natural logarithm on both sides. Do the simplification. I hope you understood the concept. Thank you for watching.